Welcome back, ladies and gentlemen. Today is the first day of 8.5, and we are using data to determine whether a linear, an exponential, or a quadratic function will be the best model of that. So the concept summary, which I hope you are able to copy onto the top of the left-hand side of your notes, describes a linear, a quadratic, and an exponential function in words, in tables, and in graphs. So first thing to look at is the graphs. Those are always going to be the easiest to recognize. And now I say the easiest, but there will be some sort of like trick. Linear, we know really well because we focused on it a lot in 7th and 8th grade as well as this class, is a straight line. So it has this constant rate of change that makes it a straight line. We know that it's linear in the function because up here it's in this y equals mx plus b form. So we can see that because we have the m next to the x and we have that b. Now, what we're going to kind of learn today and go over is what this means is that the first differences are constant. Okay? Now, we talked a lot about linear, and we knew it was linear because it added the same thing each time. Okay? That's what I mean by first differences. If I subtract 5 minus 3, I get 2. 7 minus 5, I get 2. 9 minus 7, I get 2. Now, that's the same thing as if I'm looking and I say, oh, I'm adding 2 each time, that matches my slope. Okay? So we're just talking about it in this first differences way. Now, we next went to exponential functions, where we talked about what that was. Okay, this is an exponential function. This is one that the rate of change is not constant, it's not straight, where it increases by an equal factor each time. So this is saying that it either grows or it shrinks very quickly. Okay? And when we talked about exponential functions, we said that it was being multiplied by a constant ratio. And that's the same thing we're going to talk about here. The function has that x in the exponent. So if we look at this, we're actually multiplying this by 2 each time. So when we find that constant ratio, we divide. So if I do 0.25 divided by 0.125, I get 2. 0.5 divided by 0.25, I get 2. And 1 divided by 0.5, I get 2. So that has a constant ratio each time. So it's not a difference, it's a ratio, meaning multiplication or division each time. That tells us exponential. Now, with quadratics, the y values don't have an initial relationship that we can see. Okay, so what we need to realize is that this graph is a parabola. Okay, so it's a U. I'm going to continue drawing this U because if I stopped here, that looks fairly similar to an exponential function. So we have to be very, very careful with that. But we do know that this is a parabola. And we know that it's a quadratic because it has an x squared in the function, 0.25 x squared. What we're looking for with a quadratic is that the second differences are constant. Okay, so like a linear, I'm going to subtract each time and see what are my first differences. 1 minus 0.25 is 0.75. 2.25 minus 1 is 1.25. 4 minus 2.25 is 1.75. Well, there's no relationship here. But if I take those differences and subtract those, I see that 1.25 minus 0.75 is 0.5. 1.75 minus 1.25 is 0.5. So the second differences are constant. That is what makes it a quadratic function. Okay? So I'm going to go through one example with you, and then I'm going to give you a bunch of try-its to see if you can determine whether they are linear, exponential, or quadratic. So, example number 1, we are looking at, and we want to see, and actually I'm going to kind of do this in a way that you should do this every single time, and then I'm going to make a little flow chart for you. So, first thing I want to do is have us always look at the first difference of these things. Okay, so if I'm looking here, and I find the first difference of these, okay, I'm going to do negative 1 minus 1. I get negative 2. Then I'm going to do 1 minus 3. I get negative 2. Then 3 minus 5, I get negative 2. And 5 minus 7, I get negative 2. Okay, so I'm going to just keep going for the sake of this example. But notice that we can stop right there, okay? Now, I'm going to continue and do the first differences on B and C as well. So 3 minus 9 is negative 6. 9 minus 19 is negative 10. 19 minus 33 is negative 14. And 33 minus 51 is negative 18. Okay, so notice the first differences are not the same here. And I'm going to keep going, and I'm going to do the first differences here at this one. So if I keep going, I'm going to get 1 minus 2 is negative 1, 2 minus 4 is negative 2, 4 minus 8 is negative 4, and 8 minus 16 is negative 8. Okay, so if we were to pause, look at all of the first differences here, we could say we know this one is a linear function. Because the first differences are all constant. So we can stop. We're done. We don't need to know the second differences or the ratios. We know that the first differences are constant. That's a linear function. Okay? These two, the first differences are not constant, so I'm going to continue and I'm going to find the second differences. So if I go here, negative 6 minus negative 10 is actually a positive 4. Negative 10 minus negative 14 is also positive 4. And negative 14 minus negative 18 is also a positive 4. Okay, second difference is here. Negative 1 minus negative 2 is 1. Negative 2 minus negative 4 is 2. And negative 4 minus negative 8 is 4. So, when we are looking at the second differences, the second differences here are constant. So I can say that this function is a quadratic function. These second differences are not constant, so it's not a linear, it's not a quadratic. I'm guessing it's probably going to be an exponential, but let's double check to make sure. So if I divide, I'm going to divide 2 over 1 to get 2. I'm going to divide 4 over 2 to get 2. 8 over 4 to get 2. And 16 over 8 to get 2. So, my constant ratios are all the same. So this function must be an exponential. Now, if you're looking at this and you're like, Miss Duncan, obviously you multiply by 2 every single time, you can just start there and say, yes, that's an exponential function. Okay? So, down below your concept summary, I want you to make this little flow chart. So if these examples are not super obvious to you right away, I want you to always start with finding the first difference. Okay? When you find the first difference, if it's the same, then you can stop because, okay, that's a linear function. But if it's different, find the second difference. If that's the same, stop, because it's a quadratic. Okay, so we can say first difference is a linear function. Same second difference is a quadratic function. Okay, if that doesn't work, they're still different. Then find the constant ratio. If it's the same, it's exponential. If it's different, then it's not any of these functions. Now, there are more than these 3 types of functions. You'll learn about those in Algebra 2. So there will be methods for you to figuring out other types of functions, but we're just not going to learn those today. So if you have tables that don't have a common first difference or a common second difference or a common ratio, then you would just say it's not linear, it's not quadratic, and it's not exponential. Must be something else. So what I want you to do now is look at these 5 examples, D, E, F, G, and H, and I want you to determine linear, quadratic, or exponential on these. And when you're done, then you can look at my copy of the notes to determine if you are correct.